Welcome to Pandas 4. So in this class we'll be discussing about these topics. So the very first one is multi-level indexing. So it's basically you will have a parent index and sub indices in the table for each column. We can we'll see how we can flatten these like multi-level indices, and then also how to extract data from these multi-level indices. This will happen when you do group by operations, and if you are selecting if you are operating on multiple columns, or if you are selecting multiple columns from the group by table, that is when you will see multi-level indexing. You will also see that in melting and pivoting, which is the next topic, which is melting is basically when for some reason you have columns which can be used as raw data. So suppose I have temperature and pressure, then I have some temperature value as column. For some reason I have maybe the data was data got created that way, and we have some temperature values as 33 degrees, 45 degrees, 53 degrees, something like that, and under this thing we have some labels like hot, too hot, or cold, something like that, and if we want to convert these columns into rows, like I want to place them as rows instead of columns, so that's where we use melt. Then pivot is the exact opposite. Pivot is I want to convert my I want to convert my rows into columns. So this is also called as so melting is called wide to long. Pivot is basically long to wide conversion. So that is one thing, and then finally we'll see binning. So binning is basically if we want to convert numerical data into some categorical bins, like suppose I have temperatures of the day like 33 degrees, 45 degrees, 57 degrees, 63 degrees, or something like that, and I want to so this column is standalone, not very useful if we for the stakeholder, like if he just wants to seeing a bunch of temperatures is not very intuitive. So what we can do is we can categorize. So we can create some bins. We can take min and max value of this column, and then what we can do is I'll create some bins. Let's say temperatures ranging from 10 to 15 degrees is called cold. Some from 15 to 25 it is medium, 25 to 35 it's hot, and 35 to whatever is very hot. So these are like human readable categories, right? So that's what binning is about. We can convert this numerical info into these kind of categorical labels. So that's all there is to it today. So let's begin with the first topic. Multi-level indexing. So I have already loaded the data beforehand, so that we don't waste time on this part. We'll be looking at the data set from our previous class, because this question is convenient for showcasing multi-level indexing. So the question is calculate active years for every director. So before that, let's do our usual ceremony that we do. Let's see. Pip install pandas. Pip install numpy. Then we will import numpy as np, put pandas as pd, and we'll load the data as well. Movies movies equal to pd dot read csv. The dataset is named movies dot csv, and the same thing with directors.
directors.
Okay, so we will check just check two of them. Okay, so yeah, so we have our data. Let me just do it in the normal way. I don't like this format. Movies dot head and okay, let's do the merge. Though I don't think merge is necessary for this one because we will not. Okay, we have to merge. I think there is a question with. Yeah, we have to merge. Okay, let's merge this one. So we'll do movies dot merge and wait, pd dot merge. Let me check the doc once.
Merge left, right.
Okay, pd dot merge. Left is movies, right is directors, TORS, DIRECTORS. Okay, and we will do a left merge. So the yeah, merge how. So we'll do the how as merge because the important info is the movies, right? So the left table movies is what we want. So whatever matches with the directors table, we'll keep that data, and then the rest of directors column we can. I mean, all the values that all the records that don't match, we'll discard on the directors table, and we'll keep everything in the rows in the movies table. So we'll do a left join, which is left merge, and we'll give the labels left on. Let's see, what is the left? Okay, by the way, we have this unwanted column, but I don't think that's an issue. We can, you know how to drop it by now. We can do a df.drop and then just name the column, or we can just provide an index here. There is a I think there's something called index label or something, right, in read CSV. Yeah, I guess let me just do that since this is kind of distracting. What is
too many. Okay, file path.
Okay, 1 second. I believe it was. Let me just create a new one. I don't have the df is data pd dot data frame, and we'll construct data 1 to 3 df and df dot merge. Wait, was it merge? What were we checking? Read CSV, okay. df rather pd dot read CSV. Yeah, it is index column. Okay, so index call, we'll set the index column to 0. Reload again, and do the head. So we got rid of the unnecessary column. So yeah, so we were merging the tables. Now we'll do a left on. So the left table, which is the movies, has director ID as the column, and the right table has the ID, director ID as ID. Right, now we'll call this df, and let's see what the result looks like. We have our tables. We can drop, rather we have our table, we can drop ID y, which is unnecessary, and director ID, which is also unnecessary. So we will do df dot drop ID y and director ID. Do in place. Not found in X. Okay, let's define columns. Okay, now let us look at our data frame, and we have our final data frame. Now the question is asking calculate active years for every director. So we'll be looking at multi-level indexing, but we'll look at it through these questions because that will be easier. So calculate active years for every director. So basically active years is from this table. If we have to check active years, what we can do is we can group by the director name, right, and then get the min and max of this director, which is what? Min and max of the year. So we subtract the max year, min year from max year, and then we'll get the number of active years. So that's basically how we will approach this question. So let's do a df dot group by, and we will group by director name. We'll check the groups that are there. It should be 199, and we have 199. Now we'll be operating on the year column. Now one thing to remember, if you just use a single bracket like this, this is only for accessing a single column. So if you do something like this, you will only get a single column, which if I'm not wrong will be a series. If we do an apply, lambda x, now if we just if I see GDF, and if I look at the type of GDF, you see it's a series. Now to get a data frame and see our and look at our multi-level indices, we'll pass this, we'll pass a list, and this is for accessing multiple columns, or rather applying our function on multiple group by columns. So if you remember the theory, when we do a group by, when we do a group by director name, this entire table is broken into the respective director name tables. So you'll have all these columns, but they will be grouped by each director name. So on these, so when you are accessing something like this, you are applying this function. You are applying this function on this year column of all these group by tables. So now if we see the result, you'll see it's a data frame. We access our GDF. This is how it looks. Now the question is asking calculate active years of every director. So what we'll have to do is we'll do an aggregation of min max. So we have this function, right, aggregate. So there is a special way of doing this, which is you can pass in a dictionary, and then you can say year, and I want this key, which is our year. I want min and max on this to be applied on this max and min aggregations. Now if I run this GDF, here we have our max and min here. So for this director, the max is 2015 and min is 2014. So all we have to do is subtract this min from this max value to get the number of years he has been active. So this is our multi-level indexing. So you see here, anytime you set the index, custom index, it becomes a one level lower. So if you just to show you what this looks like, the normal data frame columns, it's just a list of strings. Okay, now if we look at our GDF, this data frame, the one which we grouped by with the multi-level indexing, you will see it's a list of tuples, right? So we can again flatten this list by doing a reset index. That is obviously there. Now let's create a new column called active, and then subtract. So before that, let's just do a reset index. I don't want to drop anything, so we'll just keep it as it is. Now you see, reset index kind of changed the director name, removed the director name from indexing, but we still don't see our flattened list. So to create a flattened column list, what we can do is we can assign, since they are tuples, right? So we can just merge these two indices. So we can flatten this list to see our, again, flatten is not the correct word, but what we'll do is we'll just merge these two. So we'll do something like, we'll join them by an underscore, join CNAME, let's call this column name for CNAME in GDF.columns. Now if we do this, you will see this thing changes from list of tuples to again list of strings. And now if we execute our GDF, you will see our multi-level indexing flattened to a single level indexing, the way it normally looks like. Now all we have to do is we know the standard procedure for creating a column. We'll just do active years, and we will subtract the min from max. So GDF, which is year max, minus GDF year min. Now if we look at our GDF, you will see we have the active years, and the question is, wait, what is the question? Calculate active years. So it's just saying calculate active years for every director. We can check who was the most active, just for exploration, which so what we can do, again, just do sort values. We will sort by active years. We'll do ascending false, we'll do a descending. Yeah. So if you see, Steven Spielberg was the most active, 39 years. Martin Scorsese, then George Miller. So that's basically how you do it. You can do a reset index as well, and we'll do a drop because we don't want to keep these indices. And that's how you get it, and that's how you can flatten multi-level indexing. Now the next question is, in fact, okay, let me just show you how, let me run this once again. So see, we have this GDF, right? How do I access these values? So if I want to say access the max value, let's see, GDF, if I say max, you see it's saying key error, there's no such thing as max. So what we have to do is, it's like a list of lists. So you have to do, or it's or rather you can access it like a list of lists. So if we do a GDF year max, then we can access that list. Same with min. And since director name is at the outer level, we can access it directly. And so that's how you can access in multi-level indexing. Now let's look at the most productive director. So basically, most productive director, I don't know if you have watched the previous session, but most productive director, what we did in the previous class was we just assumed the maximum movies that a director made in that particular data set, right? But actually the ideal, or rather the correct way is, if you want to check how productive a person is, you can see we just have to calculate the total number of years he was active, and within those years how many movies he made, right? So that is the ideal measure of being productive. So what we can do is we can actually leverage the same data. Let's get rid of this stuff and run these things once again. So I'll run this once again just to get all this data. Okay, so we have our min max years of these people. So let's see, what is the question? Calculate most productive director. So yeah. Okay. So we'll have to first again group by and then get the count of the movies. Okay, so there is a slight change change that we have to do. What we have to do is we'll have to extract multiple columns and then perform the aggregation. Okay, so so we'll group by director name, and we will, since we do want min max, we want this aggregation, but we also want to perform the count on the title. So what we will do is we can just pass the aggregation. We'll do a count on the number of on the title. So essentially what we are doing is we broke the table based on the director, the movies that each director made, and on each table of these individual directors we are operating on the year and title, and on the year we are saying get me the min and max aggregation on each of these directors table, and count on the title of each of these grouped tables. Now if you see our table, you will see that we will have another column called count, and these are essentially the number of movies they made, right? Because we are doing on title, movie titles, how many movies they each director directed. Now yeah, so we have all the info we need right now, right? So all we have to do is apply the formula, which is basically movie count by years active. So we'll do the flattening first, the usual, the same procedure we did previously, which is basically, what did we do? We'll do a reset index is done, and we'll now set the columns, GDF columns. We'll do a join on CNAME, which is our column name, for CNAME in GDF dot columns. Now we have flattened it. Now let's look at our data frame. So we have our single level titles. Now all we have to do is just calculate the formula. Let's call it productivity. Productivity, yeah, let's call it score, I guess. Productivity score, GDF. What the formula is, right? So okay, yeah, we can do it directly. I don't think we'll have to create two more columns. We'll do it directly. So we'll do a max minus min, total number of movies, which is basically max minus GDF year min. So this is our total number of movies divided by GDF. Oh, sorry, that's the total number of years. This is the total number of movies, is the title count. Title count divided by, this is the total number of years. And if we check it, we will see this is the productivity score. Now let's do the question is calculate the most productive director. So we'll do a descending sort on this one. GDF dot sort values on, we'll do it on the productivity score, ASCENDING, ascending false. We are doing a descending sort, and there you go. So it looks like Tyler Perry is the most productive, followed by Jason Friedberg, then Sean Levy, etc., etc., etc. So that's how you solve this question, and that is basically single and multi-level indexing. Multi-level to single-level indices. I think that's exactly what we did. Single level to multi-level. Yeah, so you can, if we want to do single level to multi-level, again it's all dependent on the columns. So you can manually do something like we saw, right, multi-level indices had tuples. So you can do the same. We can just give the the first one was a director name. I don't think it had any. So 1, 2, 3. Yeah, let me just drop some columns so that I don't have to write for it. Or rather, that's fine, I guess. Let's see. We will do a director name, comma. Then we will do a year. Max, then do a year min, then the rest of them will remain the same, title count and productivity score. I think, if I'm not wrong, this should work. Let's see. So it's not DF. We have to do it on GDF. Don't think so it should work. One second, I think I'm missing something. GDF and look at columns. We have multi-level indices. Oh, I guess I probably have to pass it now. Oh, maybe because of that. 1 second. So I guess I'll have to run this again since I modified that. This. And I pass empty and empty. How about now? No, still no. Okay, I guess don't exactly remember, but let's see. What is the type of this one? We do an index. We pass an index. No. PD.index. Ah, there it is. Okay. So we do a pd dot index, and we pass in the index class, and that will automatically handle it as a multi-level indexing. So that is all there is to multi-level indexing. Now let's look at melting. Yeah, so now I have imported two different data sets, which is one is about the movies, which is directors and movies, and one is the medical data. So for this topic, we'll use this data because we need a special kind of data for this, which has rows, it's basically a wide data set. Directors and movies are long data set. This one is a wide data set. So we'll do pd dot. Now let's just reload df equal to pd dot read csv med data dot csv. Let's look at our data set once. So you see here, you see these don't really look like columns. These are more like row data, although you can say they are columns, but it feels like row data. It's not exact. We can actually categorize this under a single feature. So that's exactly what we'll be doing. So we'll be melting all of this into a single column. Before we proceed, let's just look at the documentation, how it looks. Df melt equal to okay, before that pd dot melt. Okay, this is a mess. Wait, pd dot melt. So see, we have, it accepts a data frame which will be passing the one we just created, and id vars is basically the columns we don't want to convert to row values. So these are the ones which we will retain. So if you see the scalar tuple list ND array, columns to use as identifier variables. Then value vars. So what this one, wait a second, column level, value vars, var name, value name. Yeah. So okay, let's begin with this one. Df melt equal to pd dot melt, and we pass our data frame, which is df, and then the value vars, id vars, the columns which we want to retain, which is, we'll pass in a list because id vars accepts a list. So we'll pass in date. We need the date. We need drug name. We I guess we need the parameter as well for this one, and we will call what is the other one? id vars is this, value vars, and var name, value name. So right now value vars, automatically all this data will be melted. Now we can give var name, which is basically the new column that this thing will create. Okay, let me just show you without this one first. Df melt dot head. So you see here, all of these columns got created here. Let me just remove the head. Got converted. So the wide got converted to long. All the column data got converted to row data. One thing that we have to remember, or rather observe here, is if we look at the df dot shape, we have 18 rows and 15 columns. Now if you look at our the melted data, it converted to 216 rows and 5 columns. What exactly is happening is, it is taking each and every one of the rows and then multiplying with all of these. So basically there are 12 if I'm not wrong. 1, 2, 3, 4, yeah, 5, 6, 10, 11, 12. So each of these values is getting 12 additional, is getting 12 rows. So that is why you have basically 18 into 12, which is 216. 18 into 12, that's 216. So that is, so that's the result. You can observe, if we see more closely, you will see, let's get rid of this one. You will see 15, 10, 20, 20, this drug, this parameter, and you will see the 130 is replicated. Let's do a head 30. This 130, the time value, we can call it time, we can call it temperature, we can call it, it's actually time, I guess. 130 is replicated exactly, you see here, 0 to 17, 18 times. And then 230 is set again another, it will be another 18 times, right, since from this point. So it's taking 130 value, it's setting 23. Then 130, it is setting the value to 12. Then 130, the NaN value. It is replicating all of this column value data those many number of times, is to retain the values, these values, right? So that is how you do melting. Now if you see here, we have, it automatically creates the column names as variable and value. Now that is where we set the custom name. So if we want to give custom name, we can give this var name. Where is it? So we do var name equal to, let's call it time. I think it is time. And I think that is temperature, pressure, right? Value name. So value name would be, so value name is this one. Let's call it temp rush. So temperature and pressure values, let's just call it that. Now if we run it, you will see the labels got created. We can give custom labels. So that is basically all there is to melting. Now if you look at pivoting, pivoting is the exact opposite of melting. It is converting long to wide. So we will be undoing this operation in pivot. So you can do something like, let's look at documentation, pd.pivot. Let's look at here. So it also accepts the data frame. We'll pass in the data frame df. Then it accepts this index. Index is basically the columns that we want to keep. We don't want to mess with these columns. So these will be set as indices. So we want the date. Excuse me. Want the drug name. We do want the parameter as well, and Yeah, and the columns is the one which we want to break it into. So columns would be the time column, and the values would be our the value column, which is our temp pressure value that we gave, right? Value is equal to temperature pressure. Now if we run this one, let's wait a second. What this will be? df pivot pivot.
What happened? Time. Have a list like key, checking indexing error will raise key error time. Was the direct cause of the following exception? Invalid index. Did we run this?
Okay. Sorry, we should pass this one, right? We are passing the wrong data frame. The melted data frame is this one. There it is. So, as you can see, we have we undid the operation. Now we can do a reset. Not reset. What is it? Yeah, reset index, right?
Yeah, it is reset index. Okay, I can forget it.
Yeah, there you go. Now the thing is reset, and we have our original data frame back. We can get rid of this time label on the index column by setting the name to null. So we can do something like df pivot dot columns dot name equal to none. Now if we check df pivot, we will have our thing back to normal. So this is how you do pivoting. It's basically long to wide. Let's see. Yeah, that is all there is to pivoting. Now let's look at the questions. Oh, okay. So I guess I didn't look at the question. Can we use pivot to find day-wise mean? Okay. Okay. So this is where pivot table comes into picture. Let's take this question. The concept is pivot table. So pivot table is a special again method which allows us to perform aggregations on the pivoting operations. You can do this pivot table underneath actually uses group by. So we can actually get this done using group by, but we'll just see how it works using pivot table. So let's see. Let's look at the syntax as usual. pd dot pivot table. Was it pd or df? Yeah, it is pd. Okay. pd pivot table. Let's look at the.
So the signature, so the argument here, it as usual takes in the data frame. Let's pass our data frame to this one.
Df pvt tbl. Let's call it this one. Pivot table data frame, and we will pass our data frame which is basically our let's see which data frame do we want to pass. The question is asking, can we use pivot to find the day-wise mean value of temperature for each drug? So here we need the temperature, right, which is our temp brush. So we'll be operating on the not this one. We'll be operating on the melted table. So on this column we'll be doing the operation. Now, no, wait a second. Can we use pivot to find the day-wise mean value of temperature for each drug? Day-wise mean. So day-wise is dates. So mean on temperature for each drug. This is the drug. So this requires us to, actually we'll have to further break this column. So it's asking us to find it on temperature. So this is our created value. So let's ignore this one. It's probably not the correct label. This is the temperature, right? So we will be breaking this parameter column further into temperature and pressure. So we'll be doing a long to wide again, which is basically another pivot. So we'll have to do a pivot on this data frame before we solve this question. So let's df pivot to pd dot pivot, and we'll pass our melted data frame. And what is the syntax again? Pivot. Right, so we passed in the data frame, we will pass the columns, or rather first we'll pass the index, which is the stuff that we want to keep. Let's see, what do I want here? Well, let me just run this again here. This is tedious. df melt dot add, just take 3 of them. So we obviously want the date, but I guess in this case, what are we breaking? Yeah, we are breaking the parameter. So yes, we need the date, we need the drug name, we need just those two. These will be broken further anyway, so I think just those two. And the columns is I want to break the parameter. Oh no, wait a second. Yeah, I think I want to break the parameter, and the values will be temp and pressure values. Let us see the result. pivot2 dot head. Index contains duplicate entry. Duplicate entries cannot reshape. Pivot df melted data. Index contains duplicate entries. Okay, we want this drug name to be there. About this one. This contains duplicate entries.
breaking those and then one second, let me pass in the time. Okay, we'll have to include all the columns. Fine. So let's do 30. So you see here we have our date. So we did date wise and then it segregated them drug wise and then time, and then we have pressure and temperature. So let's do a reset index. Reset index. So we have our normal table. Now we will operate on this one. So what we want is, can we use pivot to find the day-wise mean value of temperature for each drug. So this is our temperature, day-wise mean, so on the date. So we will do something like pivot table. What is the, so we pass the data frame. And then again index, in this case, let's see, I guess we will keep that's the question. Can we use pivot to find day-wise mean value of temperature? Day-wise. So we'll use the date here. Keep the date here. No. Date would come in columns, because so the columns act something like group by. So columns, when we specify, this is our group by column. So we'll group by the date, day wise mean value of temperature for each drug. No. So for each drug, so I guess we'll have to do by drug name. So let's divide by drug name and we'll pass in the date. Yeah, guys, this parameter is irrelevant, so we'll ignore that one. Then drug name, date. Pass in the time as well. I don't think we'll have to keep this, but let's see. Pressure is unnecessary here, but columns, and then we have to set the values. Values is our temperature, because that's what we want to find out. We want to do the aggregation on the temperature values. Then we pass in the ag function. We will pass in mean. Let's see. Okay, that's not how we want this one. No, 1 second. I think this is not how it should be. Okay, columns, drug name should be here and date should be here. Yep. So this is what the question is asking. So can we use pivot to find day wise? So this is day wise mean value for temperature for each drug. So this is each drug. These are all temperatures anyway. These are all temperatures. Pressure is as it is. These are all the temperatures for each day. Okay, so that looks good. Anything that I'm missing? No. So that's how you solve this. So basically, these are the So when we say day wise, we have to set the columns as date. Again, I think it's better if I show the documentation. So index is keys to group by or pivot the table index. So the keys index is basically the grouping argument. Then columns is the grouper array or list. So keys to group by on the pivot table column. Okay, so this is on the pivot table index and this is on, okay, so I was right. So columns is the one where you group by. So here, okay, let me just back up. So the question is asking, can we pivot to find the day wise? So day wise means we'll obviously have to categorize by the date, mean value of temperature for each drug. So we have to perform mean on temperature for each drug. So the index will be the drug and the grouping happens based on the date. I hope that was clear. Yeah, so that is all there is to it. This now let's look at the next question. Find the minimum values of temperature and pressure on a particular date. On a particular date. So again, the grouping happens based on date. It is saying find the minimum values of temperature and pressure. So it's asking for both. So we will pass the values as temperature and pressure. And we'll do an aggregation as min, because that's what it, minimum values of temperature and pressure. The aggregation function will be min, and let's look at the result. So you can see here these it is okay, it is a bit, no, it is a bit 15, 10, okay, so these are the minimum values of pressure and these are the minimum values of temperature. I guess the labeling is off, but we can always generate new labels. So these are the minimum values for pressure and these are the minimum values of temperature. So that is how you solve this one. Again, pretty straightforward and similar to previous question. Now let's look at, and that's all there is to pivot table. There is, I don't think there is anything more I have to talk about here. Let's look at the final topic, which is binning. Let's see. So binning, the idea of binning, like I said in the beginning, we just change the numerical values, something like this. So we have these temperature values, right? So we want to change this to categorical values just to get a better idea, because I mean this 14, 11, 10, 20, these don't really make any sense. They are not human readable in one sense. They are not intuitive. So to make them more intuitive for the reader, we just segregate all of these data into all of this data into separate categories. Let's see. So the method is pd.cut. Let's look at the documentation. So it is, so basically we are trying, X is nothing but the array, which is our 1D vector, which is our series. In Pandas case, in our table case, we will be operating on a series, which is which could be either a temperature or pressure or any of these values. So before we proceed, let's just construct our table. Something, I think
Yeah, I think this table looks good, right? Let's take this table. So we have our temperature data. Now let us operate on, 1 second, let's do a 3. Let's do a binning. So df bin equal to, so which is our bin data frame. We are creating a new one, and we'll say pd dot cut, and we will pass in our column, which is temperature. Okay, let's first see how this temperature series looks like, and that's our series, right? Add 2, just keep 2 of them. So let's see, what else do we pass in cut? Yeah, so we'll have to pass in the bins. We'll have to pass in the bins, and there is obviously write and include lowest. We will discuss this at the end, but basically we'll have to pass the labels and the bins. So bins are the ranges. We'll have to mention a list of ranges. So before we do this, we'll have to check our lowest and highest values of temperature. So we look at okay, let's just let me do it here. Dot max. So our max is 58, and our min is 8. So this is the range of data we have. Now we have to break this 8 to 58, this range, into some set of categories based on the business requirement. For right now, we'll do some random range selection, like we'll do a list of random ranges. Something like I can start from the lowest. Since the lowest is 8, let me show 8, because there's a particular scenario where binning has some set of rules for accepting these bins. So we'll say 8, then I'll do a plus. Okay, that's not very clean, so I'll do a 5. I'll show by 5, then we'll do by 8. So 5, then I'll do a plus 15, which is maybe plus 10. No, plus 10 would be 15. Then I'll do plus 15 maybe, or rather maybe 25. Plus 10, let's go with 25. Then 35, or let's do a 30. 15, 30, then we'll do a 45, and then we'll do a, or maybe we'll do a, we'll do a 45, then 60. Let's create 5 bins. Now we need 5 bins, but the labels will be only 4. The reason is, okay, before that let me just create the labels. Let's say this is cool, this temperature is medium, there is hot, and there is very hot. Now you see here the labels are only 4, but our bins are 5, and the reason is so whenever it sees a value like 21, it will check if it is falling between 5 to 10, or 15 to 30, or 30 to 45, or 45 to 60. So as you can see, there are only four ranges, right? 5 to 15, then we have 15 to 30, then you have 30 to 45, and 45 to 60. These are the 4 ranges, and for these 4 ranges we have 4 labels. So what is the parameter? Labels. So we'll pass our labels, labels, which is our labels again, labels. We are passing our labels in this labels argument, and then we have bins as well. we'll pass our bins argument, bins value in this bins argument. Now if we run df bins, okay, yeah, so you will see that it has created medium. So yeah, so this is our column, separate column. We'll just assign this column to our original data frame. So df bins will do something like just let's call it categories equals df bins. Then we'll check our table. You see our categories, we see lot of mediums, and 20 is medium. Is 20 medium? 20 is medium, right? This is called cool. 15 to 30 is medium. 30 to 45 is hot, and this is very hot. So let's look at some variation. Don't see much variation. We'll do a dot head to about 30. So temperatures are medium. Okay, I guess this is not the good one. Okay, let's take a different table. We'll do this on df melt itself, or rather we'll do it on this one. We'll do it on df melt because this has a convenient range here. So tempress will operate on temperature and pressure label. The value is temp press. Call it df melt categories. Let's check the data once again, and let's see top 3 of them. Yeah, so we will be operating on temp press, and we passed in the correct table, and yep. So let's look at this one. As you can see, there is a lot of range. And conveniently, we have some NaNs as well, which is yeah, because these things itself don't have, so that's I guess that's fine. But you see here, even though we have a range, even though we have a value, it's still NaN because 3 does not fall in any of our bins here. 3 is below our bin. There is also another edge case, but we'll see. Now if you see here, let's verify. 23 is medium. So 15 to 30 is medium, so that's correct. 12 is cool, 5 to 15 is cool, so that's correct. These are not available. 24 is medium, correct. 8 is cool, correct, right? 34 is hot. 30 to 45 is hot, that's also correct. 46 is very hot, and 45 to 60 is very hot, that's also correct. So that is how you create bins. Now, in order to not okay, so since we changed our table, our min and max also changed, right? So we'll have to check our min and max for this table. Temp pressure. So the max is 58 and min is 3. Right, so now let's keep this as 3 and we'll see what happens. And we will keep the max as 58. Now all of this is fine. It is cool. You see, it's still saying 3 is out of the range, and the reason is because
by default, include lowest is false. So by default, the ranges are something like this for bins. For binning, if we suppose have a range of 3 to 30, say 3 to 30 is our range, then there are three scenarios. One is the default scenarios 3 to 30 close. So if you have an open what do you call this, parenthesis on the left and a square bracket on the right, parenthesis means 3 is excluded, square bracket means the last value is included, which is 30 is included. This is one scenario, so which is included, excluded. Then you have the other scenario would be 3 is included and 30 is excluded. This is excluded, included, and this is included, excluded. And the third scenario is where both of them are included. So 3 is also, the start is also included and the end is also included. Included. So we'll be looking at these three scenarios. So since by default the start value is excluded, all we have to do is pass the value which is include lowest. Include lowest true. Now if we check this, we will see 3. Now it is within the range, so 3 is called cool, right? Now if we want to, so this is the first scenario, or rather first scenario is the default scenario. We check now the third, this scenario, where both are included. The end is also included and the start is also included. I don't know where the start value is. Let me check df, or the end value is. You can check by df melt. I want to get my categories, or rather not categories, temperature pressure is greater than 55. So you see here 58 is also very hot, so the end is also included. Now if I get rid of the end, let's see that scenario. The right is true by default. If I set right to false, so 3 is, the start is still included. We have our bins ranging from 3 to 58, which is the lowest to highest of this data set. Let's run this thing. Now you see here 58 is showing it's out of the category range. So that is the included, excluded scenario. We saw the included, and we saw the excluded as well. So that's the three scenarios, and that's how you do binning. Yeah, I think that's all there is to it. I hope that was clear, and I'll see you in the next one.